In this video, I'm going to go through two examples of using Mohr's circle. And we use Mohr's circle when we're given stresses on two orthogonal planes, and we can use this information to find the stresses on any other plane in our soil at that point in space. And as well, we can find the orientation of the plane on which the stresses are acting. So in this problem, we're given normal and shear stresses acting on a vertical plane and a horizontal plane. Okay. Given these stresses, we want to find the major and minor principal stresses, as well as the orientation of the planes on which those stresses act. So given the grid I have shown and the stresses that I have on the element, I can then just plot these as points on the grid. So on the horizontal axis, we have this. On the horizontal axis, we have the normal stress of 200 kPa and a shear stress of 50 kPa. And this is a positive shear stress because it would be causing the element to undergo a counterclockwise rotation. So it's positive shear stress. So I go over here and plot it to 200 and at plus 50. I get 1 point on my Mohr circle, and then the other point is at 100 and negative 50. And the shear stress is negative because it would cause a clockwise rotation. I can also find the center point of the circle. The center point of the circle is going to be the average of the two normal stresses that are acting on orthogonal planes, and so that would put me at a point of 150. If I draw those in with my CAD program, I have those points shown here, and then using a compass, I can draw in the circle. So I have that shown here. Now what I want to do is, well, first I can find the major and minor principal stresses without knowing what orientation the planes are on, but I'm going to wait. The first thing I'm going to do is find the pole, and then we'll show the location of the principal stresses as well as finding the orientation of the planes on which they act. So if I want to find the pole, what I do is given this stress of 250 kPa, which is shown here, those stresses are acting on a plane that is oriented horizontal. It's a horizontal plane, and so I draw a horizontal line through this point. Or I could have taken the stresses of 100 kPa normal and 50 kPa shear stress. Those are acting on a vertical plane, so I draw a vertical line. Where those lines intersect is the pole. Okay. Again, I've drawn that in with a CAD program. Now that I have the pole, I can draw a line from the pole to any point on the Mohr circle, and that line is the orientation of the plane on which the stresses are acting. Again, if I draw a line from the pole, again, this is the pole, to the point on my Mohr circle here, these stresses, if I draw a line from my pole to this point, which is a normal stress of 200 and a shear stress of 50, that's a horizontal line. So these stresses must be acting on a horizontal plane. Now, in regards to the major and minor principal stresses, by observation, we can locate the major principal stress. These stresses, major principal stress is the largest normal stress. It's a point where there are no shear stresses acting. And then the minor principal stress is the smallest principal stress. Because I drew this up on CAD, I know these points. The major principal stress is 221 kPa, and the minor principal stress, which I'll label sigma 3, is 79 kPa. Now I just need to draw a line. If I want to know the orientation of the plane on which the major principal stress acts, I just draw a line from my pole through that point, And I use a protractor to measure this angle theta. And I can do the same thing for the minor principal stress. Draw a line through from the pole through that point, and I could measure that angle and know the orientation of the plane on which those stresses are acting. So that's what I've done here with my CAD program. We could do this on our paper with using a compass and a protractor. And so now we can see that the major principal stress is acting at an orientation of 22.5 degrees, and the minor principal stress at an angle of 112.5 degrees, both counterclockwise, or clockwise, I should say, from the horizontal. So that's example 1. Let's look at example 2. Now this problem, I'm actually given the major and minor principal stresses. The major principal stress is 560 kPa. The minor principal stress is 280 kPa. The major principal stress is acting on a plane oriented at 30 degrees. See, this plane here is oriented at 30 degrees from horizontal, and that is the plane on which this 560 kPa is acting. And the 280 kPa normal stress is acting on a plane which is orthogonal to that. And so this angle must be our 30 plus 90, so that gives me my 120. And so this plane here is oriented at 120 degrees from horizontal. For this problem, we want to determine the normal and shear stresses acting on a vertical plane. And then we want to determine the maximum shear stress and the orientation of the plane on which the maximum shear stress acts. Then we start off by drawing the points on our grid. We have a 560 kPa, which is shown here to the right, and the 280 kPa on the left. And again, these are major and minor principal stresses, so there are no shear stresses acting on those planes. As is shown in the element, there are no shear stresses. And then I also put the center point for the circle in here. So again, having the center point and these two other points on my Mohr circle, I can use a compass and draw the circle in, which is shown here. Now I want to find the pole. Once I locate the pole, I can then draw a vertical line to find the stresses acting on a vertical plane. I know that the stresses, I know the stress of 560 kPa is acting on a plane oriented at 30 degrees from horizontal. So if I draw a line horizontal and get a line oriented at 30 degrees, then I'll just extend that line back in this direction until it crosses the Mohr circle, and that'll help me locate the pole. I could do the same thing with the minor principal stress. I can look at a line oriented at 120 degrees from horizontal. And draw a line, extending it back until it intersects the Mohr circle. And again, I'll find the pole. When I do that, we now have the pole located here. Given the pole, now I can find my stresses acting on a vertical plane. I just take a line from my pole, I draw a vertical line, and the stresses at this point are the stresses that are acting on a vertical plane. When I draw this in with the CAD, I find that this point is at a normal stress of 350, and it has a positive shear stress of 121 kPa. So those are the stresses acting on the vertical plane. And we could say that the normal stress is 350 kPa, and the shear stress is 121 kPa. The next step then is to go back, and I wanted to find the maximum shear stress and the orientation of the plane on which that stress acts. The maximum shear stress, we can see by observation, it's where the maximum shear stress is the largest, which we can see is this point right here. And we know that the maximum shear stress, by looking at the plot, is 140 right there. So we have a maximum shear stress of 140 kPa. And now I just draw a line from my pole through that point and draw that in by CAD. And when I draw that line, I can look at the orientation of that line from the horizontal, and that gives me the orientation of the plane. So the normal stress there is 420, but the shear stress is 140, so tau max is 140 kPa. And it's acting in orientation of 75 degrees.